Good morning, everyone. Namaste. This is Pragya, your moderator for today. I think we are more. I mean, I think there are participants other than from Nepal as well. I mean, I'm sure there are participants other than in Nepal. So, I would like to request you to accept and fit my greetings as per your time zone. So, welcome to the very first webinar of Aankura Nepal, and thank you so much for waiting on us and joining us for this very program. And sorry we got delayed for 15 minutes due to some technical issues. Um, we have a very limited time of 45 minutes, so we need to start very quickly.
Yeah.
But before that, I have a few things that I should be mentioning. First thing is that we are very much thankful to Mr. Michael Beukes, who agreed to be with us today and share his knowledge and experiences. Very much thanks to you, Mike. And
Same.
next is that there were so many participants. I mean, there were so many people who were very much eager to join this meeting, but especially the followers of Rammteck or those people who know Michael Beukes already and appreciate his works. But due to time zone differences, like in Brazil, Chile, etc., in these countries, it would be like 1 a.m. at night, so they were not able to attend this meeting. So we would like to say, or we would like to apologize for the inconvenience first, and then also would like to add that we will be recording this meeting and uploading it later on the Facebook pages of Aankura and Rammteck, so there shouldn't be any problem. I should also be mentioning that we have some honorable participations here. We can see that um, I mean our president of SONA, that is Society of Nephrology Architects, Mr. Sorry, Miss Mrs. Anjumala Pradhan, ma'am, is also present here, and
Oh,
I
wow.
think there are so many other architects or so many other um, professionals from the field. So that's a kind of an honor for us. Thank you so much for joining us again. And another thing is we are being technically supported by Mr. Ashish Takal right now. So huge shout out to Ashish as well. And next thing is like I will try to cover maximum issues as far as I can, but still there will be missing outs. Like I might be missing issues and might not be addressing your curiosities. So in case if you feel any if you feel like that, please feel free to type the question uh, and send us in the chat box. So we will be looking at them and then um, try to get the answers from our chief guest. So that's it, I guess. We are ready to go, right?
Thanks. Yeah.
So yeah, let me welcome Mr. Michael Beukes, all the way from South Africa, the founder of Rammteck. And before we start, I would like to say a few things about Rammteck. So Rammteck is a leading building company from South Africa based on rammed earth structure and um, established in 2009. Is it so? Right? It was
Yes, that's
established
right.
in 2009. uh, Mr. Michael Beukes has constructed and designed more than 25 public buildings in different parts of South Africa, all Western rammed earth structure, and has been able to to bring this forgotten art in the mainstream of building industry. And to add on, I think this is the most important part. Mike has been training more than has now trained more than 400 laymen on this very skills. Like whenever Mike goes to any kind of any village community for any project, he only takes 2 or 3 trained workers along with him, and then after that he selects the laymen from there, different other people from the particular community, and then hires them together with him. And then after the completion of the project, this people turn into trained personals. So I think he has been, along with environmental impact, he has been making he has been making socioeconomic impact in the spaces as well. So that's it. So yeah, again, welcome to the program, Mike. So we should be starting with your journey, I guess.
Yeah.
So yeah, how did you get into the Rammteck structure? Please tell us briefly about it.
Yeah. So, well, like 10 or 12 years ago, a company came to us and we needed to do some training. In South Africa, 1% of corporate money is used for training new staff. So it goes into a training skills budget. So we used this money and we decided not only to train people, just actually to build a building. And the client gave us the go ahead. So we actually found rammed earth, and we got some information off the internet, some information from people in South Africa, and we just took on this new building. So we took 14 new people that had never built before and trained them up in rammed earth. And I mean, we were also learning at the same time. And we built a building. It took us a year to build a small little building, but it was a huge challenge for us, obviously learning. And those people, the original 14 that we took, we then took some of them, and then that's how we started Rammteck. So from there on, we started using this consulting basis where we go to an area or a community, and 2 or 3 people, we take those people and we come with we come to the people and say, we're going to help you build a building. We don't come and tell them we're building a building for you. We come and say, we empower them by making them the builders of the building. So it started as something like that, and it just got traction. And yeah, so for the last 12 years, that's how we've been doing it. We moved to a community and then train them to build.
So you personally, what fascinated you in Rammteck structure, Mike?
Well, okay, so the rammed earth, it ticks every box. It ticks the labor box because the way we do rammed earth with the hand ramming, it takes a lot of labor to do that. Obviously, the mixing, etc., of the rammed earth, that takes a lot of labor, and that's the biggest problem we've got in South Africa. So I think that's what got us excited about it, was that we could take people and in 6 months where they were almost unemployed and didn't have much to look forward to in life, suddenly now they have a job, they have something to look forward to, they have a skill. So I think that's how it got traction within us. And then NGOs and things like that, because of our price that we can build at, because we can build much cheaper than anyone else because of the type of labor we're using. So no specialized labor. And that's just how it got traction. And you know, just seeing simple people construct something so amazing, I mean, that's fulfilling. That is so fulfilling, yeah.
So I think I keep on getting distracted seeing myself in the video. I'm really sorry. So yeah, I think we should get into the technology itself. So let's talk about RAM mod technology, but I think it would also be better if you could give us a small brief presentation or slide sharing on one of your projects that you're very much proud of till date, so that we can have some, like a basis for the I mean for discussing
Yeah.
all the issues around it. Is it
Okay,
okay?
so yeah, so I mean,
Or
if we take,
and
yeah.
along the process, you can tell us about ramped mode technology as well. So how is it? What is it? How is it done? And all.
Okay, so basically, rammed earth is taking sand, putting it in layers and ramming each layer at a time and creating walls inside shutter work. So you put up a shutter, you start by layering, and I mean, when we're ramming about 10 centimeters of soil, and we ram it down to about 50 or 60. And the reason we do only 10 centimeters of soil in a shutter would be to get the right amount of compaction per layer. So your layers mustn't be too big. You compact them down, and then you pour your next layer in. If we're coming to soils, different soils that you can use, there's a wide range of soils. People are ramming with just clay soil and mixing gravel and sand into clay and using that as rammed earth. So that's unstabilized rammed earth. And in South Africa, we do stabilized rammed earth. So it's a bit different from unstabilized, where unstabilized, if you know the hardness of unstabilized, it's about 3.5 MPa, which is not very hard. But stabilized rammed earth, you're probably looking in the range of about 6 to 8 MPa, which is very hard. You can build multi-story with that. So in South Africa, we only use stabilized rammed earth because of the type of rainfall we have. So when the rain falls in South Africa, it's big storms, sideways rain, it never falls straight. So with a clay building in South Africa, you've got problems because you can't cover it well enough. So that's why we do stabilized rammed earth. And I mean, we've had tests of stabilized rammed earth up to 23, 30 MPa once we've finished and let the building stand for a while. So the building will get harder and harder for a few years. But obviously you're trying to keep water away from it. You don't want too much water on rammed earth, and then it will last long. So I don't know if you want to discuss some soil science maybe, Pragya?
Yeah, sure. I mean, okay, so on that note, you should be giving us a little background about South Africa's climate and then soil and other stuff, because
Okay.
I think, yeah, it would be
Yeah.
good.
Okay, so South Africa, we have like a very varying climate. So obviously winters are cold at around 0 degrees, and summer in some areas can get up to 40 degrees Celsius. So when we build a rammed earth building in South Africa, we take into account the layout of the building. If it's laid out from east to west, that's how we try and lay out. A long building would be laid out east to west. And facing on the northern side, we'll have some windows and things like that. On the southern side, you would have no windows. So it's completely different for you guys out there in Nepal, because
Yeah, we are in Northern Hemisphere.
yeah, so you'll be looking the other way, where you'll put windows on the south and shut down the north. So the reason we put the buildings east to west is so that on sunrise, we've got sun on a small part of the building, and at sunset, we've got sunset shining on a small part of the building. But all the way through the day, it's in the shade. So the building's in the shade all day in the summer, creating a cool building. So as long as you've got good insulation on the roof, you've got a cool building. And then in the winter, the sun cuts lower through, cuts lower through the sky. So that shines into the building the whole day on a winter's day, and that will warm up your building on the northern side for South Africa. So that's how we control the temperature in the buildings. In the summer, you've got no sun on the building, and in the winter, you've got sun shining through one side of the building continuously during the day, warming up the building. So that's how we sort of centralize the temperature. Now, what's interesting about rammed earth is it's always 12 hours behind the outside temperature. So it's quite an interesting fact that at lunchtime, your rammed earth is still catching up to the temperature before it starts cooling down. So rammed earth will take the center temperature. So let's say I go from 0 to 10 degrees every day, my building will be 5 degrees. And that's how it will run at 5 degrees, unless you put sun on it, obviously in the winter, that will give you a bit more warmth. So that's a good idea.
Yeah, I mean, it's really interesting, but I think most of us here, as who are here as a participants, we are modern practitioners and we don't know much about rammed mud technology and all. And I think it's being hard for us to visualize as well. So if you, I thought you would be sharing some pictures and all, right? Are you not ready for screen sharing, right?
No, I'll have to reference to my website or to my Instagram page. I think if we can do that. I don't know if you've got a pulling it up.
Okay.
Can you pull up the pictures?
Yeah, that's also fine. So, I mean,
okay.
so yeah,
Okay, so
yes, continue what you.
yeah, so okay, so basically, I think rammed earth suits a certain demographic. What we found in South Africa over the last few years is that the people that grew up in poor regions or grew up in mud huts and things like that, they struggle to see the advantages of rammed earth until it's actually been put in front of them. So if you explain to them, we're going to build you a sand building, they're actually like, you know what, we don't want a sand building, until they can feel the actual rammed earth and see it being put together. You know, there's no understanding of rammed. If you tell someone you're getting a sand building and it's a rammed earth building, it's the two pictures don't match, because people imagine a mud hut, but what you're building them is a better than brick structure. So that is difficult to overcome in South Africa, as far as the poorer communities accepting rammed earth as a proper building material. So in a lot of our communities, when we go there and we tell them what we're going to do, they're very hesitant until they see the first wall being built, and then they're like, oh, okay, no, now I see what we're doing, you know? So you have to sort of overcome that first stumbling block where people think sand building, but rammed earth is completely different.
Right. So we should be, I think, talking about the different pros and cons. I think you said a lot of positive thing about rammed earth structure.
Yes. Yes.
What about the negative sides?
Okay. Yeah, there's definitely negatives. So if I'm going to build a building in a region which temperatures are very low, so let's say our maximum temperature is 10 degrees and we run towards the negatives, then I would definitely use insulated rammed earth. And the reason being is that because rammed earth finds the center temperature, you find you're living in a tomb, because the rammed earth just gets colder and colder and colder. So even in South Africa, if we have 2 weeks of very cold weather at a rammed earth building, you're going to start freezing inside, because the temperature drops of the rammed earth and just keeps dropping. There's no sun to warm it up. So it just keeps on dropping the temperature. So that's probably the worst thing about rammed earth. In England and stuff, they do double walls, but they put insulation in between. So that would, like a polystyrene or something insulator between the two walls when you're building, so that the outside wall is affected by outside temperature, but the inside wall is warmed by the house, the internals of the house. So that's how you would stop it. That's probably the other thing about rammed earth, is it's labor intensive. So if labor is expensive, then it's probably not the cheapest way to build. And probably the third worst thing is if you haven't got your own sand. So if you're buying sand to build a rammed earth building, it will cost you more than a brick building. So we've done it in South Africa, where we work in some places where we actually can't get sand or harvest sand, and it works out more expensive than a conventional building.
Mike, I'm still confused about the composition of building materials. I thought it was soil and then sand and some amount of cement, no?
Yes.
So what is composition? So is it
Okay,
like sand maximum?
Yeah. Okay, so so if you're looking at the composition of the mix, so a lot of different sands can be used. What we preferably try and use is any sand that's got less than, I'd say, 20% clay. So anything with less than 20% clay, you can then bind with cement. Let's say if you've got a soil sample that's got 50% clay and 50% gravel, etc., you're going to struggle with cement, because cement and clay, they work in different directions, you could say. So when they're binding the actual particles of the sand, they're fighting each other. Clay pulls one way and cement pulls another way. So sometimes you'll find if you put cement into a clay sample, you're actually making the clay giving it less strength. So you're taking the strength away from the clay. So if you've got over 50% clay, I would use clay to build the building and ram with clay. And then obviously just make sure you cover it properly with a proper roof. But normally our soil samples, it's a range of samples. So from your smallest particles, which is your loam or your fine powder in sand, all the way up to a grain less than 10 millimeters. So if we get to a site and we're harvesting soil, we put it through a 10 millimeter sieve, and whatever comes out of the sieve less than 10 millimeters, we can use into our rammed earth walls. So soil grading, you would, like a river sand, a plaster sand. I think everyone knows a river sand, a plaster sand, and then a building sand. If you mixed all three of those together, you'd have the perfect mix for rammed earth. So it's fine particles, a little bit bigger. So you've got a whole range of particle size. And obviously your particles, you must try and make sure that they're angular. So just look at your little stones and make sure they've got angles on them, because it's those angles that bind to the next one. The cement helps it bind if it's angular particles.
I
What else
want
would
to
you
do a
say?
since
Right?
Mike, okay, so I want to share some pictures of Mike's work. So I'm trying to share screen. Just a second.
Okay,
Mm, okay, this one. So this is the kind of building that Mike has designed, and
that's that. Yes.
so what fascinated us in the first place was this amazing patterns that Mike has created and created in the wall. You can see the texture, and the beautiful part is that like it's from the composition of building materials alone, right?
Yes. Yeah.
So you
Yeah.
are not applying anything extra out in the outside wall. So
No.
how do you bring that composition? I think that's the most interesting thing about your work. See,
Okay.
these are the kind of patterns.
Yeah.
So it looks like wood texture, but actually it's just the composition of soil and building material.
Yeah.
So
So
yeah,
we were
my audience would be interested to know this, like how do you do so?
okay.
And
So this building, it's quite unique. When we were digging on the site there, we found some nice red sand, and we found a very fine gray sand. So we had two definite colors that we could use. Everything here that you can see has got 10% cement in it. So it's all stabilized rammed earth. Um, you can see the different colors there. So the red color is also, we just use 10% cement and mixed with water. And obviously we ram it into shutters. So we had a lot of curved shutters that we used for this building. And then it's just rammed in those layers. So
such means like formworks. Is it like formwork?
farm
Like
formwork, yes, yes, shutters, yeah. So shutters is
okay.
formwork or the curves, yeah. So these
Mm,
walls are all 300 millimeters wide, and we put in, we've got steel shutters that we used here, just that they can be used over and over again. And you can actually see the shutter lines. If you look at that picture, you can actually see the shutter lines where the boxes were attached to the wall. You can see the frames, the little lines there that show you each shutter. So each shutter is then bolted on one after the other as we go up, and we work at about a 600 lift so that you've got space in the shutter so that you can work in the shutter nicely. And then the next day you can basically take off your shutter and move it up. So all this soil, yeah, it's two different types of soil with 10% cement. And then what's important once you've done the rammed earth wall is just to keep it wet for the 14 days. Because cement takes 14 days to harden, you must keep these walls wet for 14 days after you've taken the shutters off.
oh, so um, so this is the another mini sample of
Yeah,
Michael's work.
yeah.
Sorry,
That,
just uh,
you're a farmer.
sorry, I downloaded something.
Yeah,
I
so
should something screen sharing. How do I do it? Okay, I'll just keep Mike's work. I don't know how to stop this thing. Okay, so
can we
yeah,
answer the, yeah.
I think we have not talked about the strength. So what's the strength? Like what is the strength capacity of this kind of buildings?
The strength?
Yeah,
Okay,
like
okay.
like how many
So,
floors up to
yeah,
um go and then
okay. So a
um
standard, yeah, we can talk about the hardness. So a standard cement stock brick in South Africa, and SABS, that's our testing, South African Bureau of Standards, stock brick would be about 9 MPa. So that's 9 megapascals. You can do the conversion. So that's a standard stock brick in South Africa. And with a standard stock brick, you can build 3 stories high. where we, on our rammed earth, once we've tested it, we're getting close to that 9 MPa, but we're getting 9 MPa over a much thicker area. So instead of a 220 at 9 MPa, we're getting the same hardness, but with a thicker wall. So rammed earth in England has been done up to 5 stories with chalk, just by ramming chalk. So now that we're using an aggregate like a river sand or something like that, where we've got some stones in the mix, then we can definitely you know make well. It's a much better product because you're getting a hardness over a thicker area. Rammed clay, if you're only using clay, you're probably going to get just around 4 MPa to 5 MPa. And already that's been used for a double stories, 2-story buildings, and it's just out of clay. But then they're not using a concrete slab, they're using a wooden slab or, on top, so that they're not loading the clay too much. But so obviously the stabilized rammed earth gives you much more strength than a conventional brick wall. The thermal mass, because rammed earth is just so heavy, that also helps it obviously hold on to temperature, but it is a very hard, solid structure that you're building. It's also very good, obviously, at soundproofing and things like that. Because of its thermal mass, it sucks up the sound. I know when we were building classrooms, you used to stand inside a classroom and the kids would play outside and you couldn't hear a thing. You couldn't even hear the kids playing in the playground because of the properties of the rammed earth, the hardness and the solidness thereof.
How about the earthquake? Like we come from earthquake prone area. We had an earthquake in 2015, and
Yes.
I mean there's some kind of like a repeated pattern of having earthquake in every 100 years in Nepal, almost approximately. So what's your like takeaways regarding earthquake? Have you built ever in any earthquake area, or like what's your suggestions or recommendations for it?
Yeah. So, okay. So all the research I've done on rammed earth in earthquake regions, I mean, in China, it's used extensively with reinforcing in earthquake regions because rammed earth is probably the most stable thing in an earthquake region. So what they've said is, as far as class of earthquake, a stabilized rammed earth wall that is over 300 thick is probably one of the best things in an earthquake region, the best structures in an earthquake region. There is there's a lot of studies online about it, but basically what we're saying is rammed earth, it must have steel reinforcing inside, and then it's basically an earthquake. I wouldn't say earthquake proof, but it's more resistant to earthquake than your conventional bricks or anything like that. The only other thing that's better is obviously a concrete structure. So as far as building material, rammed earth is very good. They say either, they say because of its thermal mass and because of the way you've tied it together, we do a lot of horizontal reinforcing in rammed earth. So in South Africa, we actually build it as if it was in an earthquake region. The way we build it here would suit an earthquake region perfectly because of the way we reinforce and stabilize the rammed earth.
So I think the reinforcement involves like some straps or some bindings along the horizontal layers, right?
Yeah, so as we're ramming, we would ram a 300 layer and then we'd put in a wire reinforcing and then carry on ramming 300 high, put in another line of wire reinforcing. So what this wire reinforcing does, obviously, if there's an earthquake and there's a wave that shakes through the building, the wire reinforcing will hold everything together. So you're going to get cracking in the building, obviously after an earthquake, but it's not going to fall down. It's not going to break down on itself because you've tied it together with these wires. So the wires give it some sort of plastic properties where it can bend and come back to itself. So if you're in Nepal, I think a lot of houses in Nepal are built with just clay and they're not built with cement stabilization. That is a bit of an issue.
No, we have mud houses, and
Yes.
then we have There's different bricks that are sun-dried and all.
Okay.
And
Okay.
so
So they're basically saying that those are not, they're not physically capable of doing an earthquake. So they're definitely saying that if you're making mud bricks, you might as well just do rammed earth and you'll get a much better.
actually, actually, that's not completely true. Like there are so many traditional buildings and traditional technology in Nepal that can, like they have this who can join kind of technology that can completely withstand earthquake. Like we have different temples and build historical buildings standing since ages. I mean, like with bearing different earthquakes of different time periods. It's just that when it comes to personal houses, I mean, individual houses or residences, then obviously like people would not have like applied proper technology, and
Yes,
also because these houses have like already been more than 100 years and all, so that's why like mud houses were destroyed in earthquake of
yes,
thousands, let's say. Otherwise, we have technology that can, especially wood technology that can, like
that's
withstand
more
earthquake.
resistant. Yes, yes, yes.
Yeah, yes, and we have interesting architecture here as well. Uh, so I think we should be anything like what are the considerations that need to be done when it comes to RAM technology?
The
Like, are there any things that we need to consider when it comes to RAM technology?
I think it's just, you know what, I think there's two important things when you're doing rammed earth. The first important thing is obviously your soil and how you, where you're sampling your soil, where you're harvesting your soil, at what level you're harvesting. What we try and do here is first you excavate the topsoil, which is the live soil, and you want that soil underneath, which is called the subsoil. So you want subsoil, which is dead soil. It hasn't got any life in it. That's the soil you want to try and harvest and use in your buildings. So you want to try and clear away the topsoil and dig down to get that subsoil, the dead soil. So the one that's got no organics in it. So obviously there's two things that are most important as far as quality of rammed earth. And that's the first one is the soil that you're getting, you're harvesting. And the second is the mixing process. So I tell a client, I always tell clients that the quality of rammed earth is done in the mixing. And it's not an easy process to mix, to make sure that when you're mixing cement into a mix, that you're getting a continuous mix throughout. So what happens while you're mixing cement into soil, you get little balls that form, and those balls you can't mix into the mix. And those balls are just full of sand. They've got cement around them, but it's a little ball of sand inside. So it's very important, the actual process of mixing, that's the quality of your rammed earth. So good rammed earth is good soil and obviously good mixing. So a lot of supervision, making sure that your labor mix correctly, because that's where walls fail, is in the mix.
So, and what about the roof or slab considerations? Like, what goes well with the rammed earth structure?
Sure. That's an interesting question. I think in the
You're
areas where
tired.
we've built rammed earth, we've always tried to harvest water. So we would go for like a steel roof, the biggest collection area we can find. So wherever we've built rammed earth, we've tried to, put in a second system of water, of harvesting water. So there we've used a lot of steel roofs. We've
Mm.
put one or two thatched roofs on rammed earth buildings, but again, we're sort of losing the water catchment. In South Africa, it's important to catch every drop. So that's, I think, why we like our steel roofs on top, and that's just for water collection. But you can do anything on rammed earth. Before you get to the top of your rammed earth walls, we like to put in a piece of reinforcing. And from that reinforcing, let's say 600 down on the top of your wall, we would then run wires up from that reinforcing, and that would there be to hold down your roof structure, whatever you want to put on top. So the actual reinforcing is lying in the top of the walls, but then we ram on top of that and then hold the roof down with wires or hoop irons, you know, to make it a proper structure.
Mhm. So I think we should be taking questions from our participants. We have so
Yeah.
many questions. Okay. So yeah, I missed out the important things. I'm really sorry. So what about the foundation? Like, what can you elaborate us a little bit about the foundation details for ramped earth structure? It's Mr. Rajiv Awale asking.
Okay, so there's a few. So what we normally do in South Africa is a standard concrete foundation, and you can work out the thickness of your foundation by the height of your wall. So they say rammed earth, the height of rammed earth shouldn't be more than 8 times the wideness of the foundation. So if you just work to a tenth, if your wall was 8 meters high, you would have a 1 meter, a 1 meter wide foundation. So you can basically work on that formula. So it's 1 to 8. You can put in steel reinforcing into foundations. It is, if you're going to go over 15 MPa, you know, as hardness on foundations, then you would put in reinforcing. You can also put in upstand bars. So in some walls, very high walls, you can put in an upstand bar, which comes, so it's basically the bottom of the bar is mounted into the foundation and the bar stands up, and then you ram around that bar. And upstand bars work very well as far as keeping rammed earth from falling over either way. So in Nepal, I would definitely put in upstand bars from your foundation, just to create that extra strength on, you know, holding the walls vertical. So it's standard foundation, concrete foundations, and I would just go 10 centimeters on each side of the wall, and then you know you've got it covered as far as foundation. So 300 thick, 10 centimeters on each side of the wall. So
So I
300
think
wall would have a 500 foundation.
so. I think our one can see the pictures and the videos in Instagram as well as the blog of Rammteck as well for more
Information.
visualization, more information. Yeah.
Yeah,
So
yeah.
next, it's Mr. Romeo, but but we okay. I don't know how to pronounce it. I'm skipping it. So he says, I've done university studies of rammed earth in Philippine climate, specifically erosion due to rainwater, and it works well, very resistant to erosion. However, prolonged exposure would be detrimental, so it would still be wise to have overhangs above it. I think it's a
Yes.
statement rather than question.
Yeah. So
Do you have
yeah,
any?
we've, we have already answered it, but continuous wetting of a rammed earth wall will damage the wall. So you do want to keep it water away from it at all costs. We have got a water repellent that we use here. So it's a paraffin-based water repellent. I think everyone knows paraffin. If you paint that onto your rammed earth, you'll protect it from moisture because it will create like a moisture barrier. So it does definitely, it's a paraffin-based water repellent that you can use, or just straight paraffin onto the wall will create a barrier for moisture penetrating the wall. But big
Okay.
overhangs, 600 to 800 overhangs on your roof, and that should take care of the problem.
So you just apply it as the outer coat on the
Yeah.
wall
Yes,
in
yes.
order to protect from moisture. Okay.
Yeah, that will just protect it from getting wet, you know, or moisture penetrating. Because rammed earth, obviously, it sucks up moisture. It loves moisture. That's why every rammed earth building, you'll never find mold inside a rammed earth building because it's always controlling the moisture content in the air.
So okay, I think we are good to go on another question. So
Okay.
when building longer continuous wall, do you add reinforcement steel into the walls and how much horizontal and vertical? So yeah, so what do we need to do in case of longer walls?
Yeah. So the longer the wall, I mean, if you've got long straight walls, I would definitely use upstand bars. So that's steel reinforcing that comes out of the foundation, and then you're ramming around that. If you're going to go do long straight walls, um, as we're going up, I was saying that every 300 layer, so we ram a layer of rammed earth, in 300, at the next 300, we'll put a piece of wire reinforcing in, and then we go up 300, 300, 300. I think our highest wall we've built is 7 meters high with a 300
Mm.
wall and with no vertical reinforcing in it. So vertical reinforcing, I would put on corners, and that's basically it. We don't really use vertical reinforcing all the way to the top unless it's on a corner or we want to use it to hold down the roof, you know, from the top. So we
So
don't put
you
much
run.
vertical. Yeah.
Okay, so how about the steel bands or concrete bands, like for higher walls? But you said I think only up to 7 meter you go, right? Is that
Yeah.
for story?
Yeah, so I mean, you can put in ring beams and things like that right on the top of anything. So let's say we built a 7 meter walls all the way around. It would be a good idea to put in a concrete ring beam on the top of that and then tie that back to the rammed earth just to create a solid structure on the top, you know, to give it rigidity on the top of the walls to join them together. So if you were doing a corner in rammed earth, then I would do that as well with a concrete block at the top with some reinforcing going around the corner, just to create a structural join there. But as far as straight walls are concerned, you can put 1 or 2 layers with a higher cement mixture in them, and that will create, you know, stiffer beams in the rammed earth. So if I was building a clay rammed earth building, I would definitely put in a concrete ring beam around the top. And that's just a beam to give it stability.
So there's another question, like, is there any chance of alternative of sand, as in many rural, mountainous and hilly region, there is very small chance of sand availability?
Of?
Do
Just,
you have
sorry, I
any,
missed it.
like, yeah, so do you have any option other than sand? Like, what can you use instead of sand, alternative for sand?
I don't know. How do you ram this? You talk, you know, as far as alternative buildings, I'm not sure. I would use sand if it was mine, but I don't know.
Okay.
I'm sure there's a lot of stuff on the internet about that. Yeah.
So,
Oh, I've got the questions up here.
yeah, how do you do joineries for the windows? Any protocol for electrical conduiting, Mr.
Okay.
Natarajan? Like, how do you do joineries for the windows?
Okay. So basically, for the windows, on the top of the windows, we'll create a lintel. So I know in earthquake regions, they say you should go at least 500 into the wall that's next to the window to create your stabilization over the window. We normally just put an extra, a little bit of cement into the sand mix, and we put rebar, maybe a 8mm or 12mm rebar over the windows and ram that into our shutters. So we're basically creating a lintel over the windows. So if you look on my buildings, you'll see that there's a little gray patch over each window. And that's basically where we've been creating the beam that goes over the window. So on all my buildings, you zoom in, you'll see the little gray line over each window. That's where we've created the lintel in the window. And then so once you've rammed, obviously when you take off your shutters, you've got a hole for the window and your window fits in, and then you screw the window into the sides of the rammed earth or attach it like that.
You can drink water. I think you look tired by
No, I'm
continuous
fine.
talking. Okay. So, like,
What other questions you got there, Connor?
yeah, so your next question is, what is the structural ratio of wall thickness and height?
Thickness and height. So yeah, I would work on that 1:8 ratio. So I'd say a wall that's 500 thick, you could build comfortably to 5 meters high. A 300 thick wall, I would stick to about the 3 meter mark on a 300 wide wall. You can probably push it a little bit more if it's got corners and things like that for stabilizing. So work to the 1 to 8 principle on thickness of wall as to the height.
So next is like, is it possible to construct multi-storied buildings too? Is this
Technology safe. Yeah, so if you're doing a
I think
stable, yeah, if you're doing stabilized rammed earth, there's no problem. You can go as high as, you can go up to 5 stories. It's not a problem. I would obviously do more testing as per the soil to make sure that it is capable of doing the 5 stories. I wouldn't build you know, an unstabilized rammed earth building, obviously higher than a single story. But I think stabilized rammed earth, it's fine. If you can meet the criteria of hardness, then you can build it. As I was saying, it's better than brickwork. So just make sure that once you've got your sample of rammed earth, you get it tested by an engineer, whatever, and make sure that you've got the right hardness before you go ahead and do a multi-story building with rammed earth. There is a guy in Thailand who's building 4 or 5 stories with rammed earth. So it's definitely a possibility.
so. Next question is, what is the material of reinforcement wire? Would the reinforcement wire covered with concrete?
No.
That's
So yeah, so the reinforcing wire, we just put between the layers of rammed earth. And what you do is you put your soil into your shutter, you leave it loose, you push your reinforcing into that layer of soil, and then you ram that layer of soil. So the layer of soil basically catches the wire inside, and that's how we would do it every 300, every spacing of about 300. So you would use, and that's horizontal reinforcing. So every single time you get to 300, you put your line of wiring in. That will stop a wall from failing in this direction, that way, because obviously the forces of the wire hold the wall together in a straight line. So that would stop this kind of breakaway, as well as walls shearing off. So in earthquake regions, with the wire in the wall, it would stop the wall from shearing off that way. So because the wire is there, it will go and crack, but it won't fail. What other questions we got?
Please, I have a question. Okay.
You got it?
Trying to say anything? I don't know. So next is like the images.
I see. Yeah. What's your take on mechanical ramming versus manual ramming? So, okay. It depends on the look you're going for. If you ram by hand, you're going to get a better quality, a finer finish. If you're ramming mechanically, it's a faster process. You can do the work faster, but you're not going to get the same finish as hand ramming. So hand ramming is more an art form, and mechanical ramming, there's not much art in it because you're just ramming sand into a shutter. So there's no definite lines or where it starts and stops, things like that. So it's the definition that you're going to lose with mechanical ramming. Hand ramming is obviously something done by hand. It's more fine, it's more precise.
So how about the time difference? Like, I mean, how long it will take if you do with hand, and how much faster it will be?
Yes.
Like compared
Okay.
if you do
So
mechanical.
a good example is that a hand rammed wall will probably take double the time as a mechanical rammed wall. Mechanical ramming is very fast because it's a different process. I mean, while you're ramming, the guys are pouring sand in continuously while you're busy with your rammer. Whereas hand ramming, you ram a layer, you pour, you ram a layer, you pour. Where mechanical ramming, you're busy pouring all the time and you're ramming all the time. So it's much quicker, definitely much quicker to do mechanical ramming.
So, I mean, I definitely know that it depends as per the size of the building, but how long does it usually take for you to complete one project, Mike?
Yeah, so with a team of, I always say, with a team of 10 people, we can do, what's it, 5 square meters per day. So a team of 10 people can mix and ram 5 square meters a day of I know that was on 400 wall that we used that example. So 10 people, 5 square meters a day, 400 thick.
So that means like someone who is physically weak or doesn't have much muscles cannot do rammed earth
Ach, no, you know
structure
what?
and all.
No, you know what? What we try and do in South Africa is half our labor force is actually women. So we split it men and women, 50%, 50%. And the women do the ramming, the women do mixing, they do ramming, they do everything. I mean, a ram is only a 7 kilogram weight. So it's not very heavy. It's easy to operate and to ram. So even women can do it. It's not a problem. I mean, one of our best staff is a woman. She's been with us for many years and she's rammed a whole lot of buildings.
Okay, so let's go again to the question. Natarajan again says the images that Pragya showed had literally no roof overhangs. Mike says we should not be really exposing the walls directly to heavy rains, even
Yes.
stabilized. What kind of hydrophobic coatings do you use there in South Africa? I think you already answered. You can just take the name of the
Yeah.
what the
So that
mixture that
building, yeah, that building with no overhang, we've obviously put a sealant on the top of the rammed earth wall. The most damaging water for a rammed earth is water that falls onto the top of the wall. Any water that falls onto the side, the rammed earth wall can deal with it because obviously it just spreads the moisture throughout the wall. But water that comes through the top of rammed earth is dangerous because that washes out the lime. So it goes into the wall and it washes the lime out of the wall. So it actually weakens the wall by falling in the top. So as long as you've sealed the top with a proper sealant, then any water that's coming from the side is not a problem. But that specific building, we've used that water repellent around the top 2 layers, just to stop the water from entering high up on the wall.
Is it possible to remodel rammed earth home, for instance, as over time we remodel concrete homes as we desire later?
I don't, maybe I should read that question. I didn't understand it.
He's saying like, okay, oh sorry, okay. So lovely Ranjana says, is it possible to remodel rammed earth home? For example, in over time we remodel concrete homes as we desire later. So it's saying like maybe can we change the side interiors and all? He's asking on that aspect.
Yeah, there are definite ways of rejoining it. But obviously when we're building rammed earth, if we're going to go to a corner or to a wall that's going to join against it, when we take the shutters off, we've already got wire in there that we can pull out and put into our next wall. So that's how we like to join them. But if you're going to buttress up against a rammed earth wall, you're going to need some sort of a pillar because rammed earth moves on its own. Summer, winter, the moisture in the air, etc., creates movement in the rammed earth because it's a living thing. Remember, it's not solid concrete. So if you're going to build up against it, you can actually build a pillar up against it and then build away from it. So yeah, you can remodel it. It's obviously the engineering is important to look at.
I think we're getting so many messages. We have like 17 new messages.
Yeah, how to take care of tie rod holes. I see there. Yeah, so obviously what's important about rammed earth, if you don't want to see the patch marks, you must fill the next day. So while the shutters have been moved off, you take out the bolts and you use the mixture you're going to use that day for ramming to fill those holes. And it probably will vanish if you do it at the same time. If you come back after a month and patch it, you'll always see the. Oh yes, so for shuttering, we use a mixture of diesel and cooking oil as shutters.
We'd like to request participants to mute. Okay, done, Mike. You're easy to go now.
Okay, thanks. You got it. So we would use a mixture of diesel and cooking oil, or just diesel is good for your shutters. To clean your shutters, yeah. Oh, and then a wooden shutter versus metal shutters. So wooden shutters will always give you that wooden finish. it works well as long as you put a lot of reinforcing on your wood, where steel shutters gives you the perfectly smooth finish. So there is a big difference between wood shutters and steel shutters when it comes to the finish of the wall. We have found that with steel, it's much smoother. With the wood, you get like a wood texture. It's not, we don't really use wood because we like to reuse our shutters over and over again. And instead of hiring a carpenter to work with you continuously, you use steel shutters. You know? Then sand in India and Nepal is river sand. This was a smaller gravel to use along with the clay and loam. Is there a replacement for that? I see there's a sand question there. Question sand got missing. Sand in India and Nepal is river sand. Oh, well, that's perfect for stabilized rammed earth. Please specify that was regarding smaller gravel to be used along with the clay and loam. Is there a replacement for that? No, I'd say there's no replacement. If you're going to use clay, then you do definitely need river sand in that mix to create some sort of a strength in your clay. So to up the hardness of your clay, you would put river sand in or a finer plaster sand. And then formwork, obviously steel formwork is the most expensive, but wooden formwork is the cheapest and anyone can do it. I mean, you can, you know, like this, the little pot that we showed earlier, this is just some shutter ply that was done, no supporting, no reinforcing. You can see inside, it's just the same shape inside. So it's just simple shutter ply that we put together for this mold. Shutter ply gets soft over as soon as you get a bit bigger, but then you would put in cross planks and support planks, etc., just to create your shutters. So wooden shutters if I was doing a small house, but obviously on a more commercial level, you would use steel shutters.
Okay.
I see the sand clay ratio for rammed earth mix. So again, if you're doing a good rammed earth mix, if you're going to do stabilized, I would go less than 20% clay in your mix, and then a range of soils over there. So particle size would all be different, but I would use less than 20% clay. And then obviously if you're doing it with, if you're not stabilizing with cement, then I would be at least 50, 60% clay in your mix, and then with additional aggregates in there. Am I doing all right, Roka?
Yes, I think we are getting it. Yeah. I mean, we are tiring you.
No, it's 18 inches. How thick is that in centimeters? What's that, like 18.3? That's like a 400 wall, isn't it? 18 inches.
450.
450. Yes. So then you can go to 4.5 meters if it's a stabilized rammed earth wall. So remember that if it's a clay wall, I still wouldn't push it, but on a 450, you could go to 4.5 meters comfortably if you've got a rebar that's coming out of your foundation. So use upstand bars, and it's not a problem. Although 450 wall is very stable. I mean, that thickness is incredibly stable. There, we've built that over 8 meters in Joburg. Yeah.
Okay.
Okay, there's skilled and unskilled personals. So what I said we normally just put 2 skilled people and they train a whole team of people to build buildings. So you really need unskilled labor to do rammed earth. It's very quick to teach them how to mix properly and how to ram properly. Electrical, so we definitely put conduit into the rammed earth. Obviously, when you're ramming, you must just be gentle around it so that you don't break it. But all our electrics come up in the center of the walls. We ram around the pipe and then turn the pipe and put the box here on the face of the wall. So your conduit would come up, it would bend like this. You would ram this layer, put your conduit over, and then ram it closed. So basically your conduit comes up the center of the wall and then into your back of your electrical box. And the electrical box is sitting on the front of the shutter. So once you take off your shutter, your box is waiting for you. So all pipes and electrics can go through rammed earth. That's not a problem. Okay, the paraffin coating, I think it's a good question. It doesn't last long. That's why we actually buy it. We buy a thing in South Africa. It's a paraffin-based thing, but they've got some silicon, like a liquid silicon that they actually add into the mixture to make it long-lasting.
Okay.
So I'm not a chemical guy, so you should go to them. The mix ratio. So mix ratios, we use 10% cement. So if you take, let's say 8 wheelbarrows, no, let's just say buckets, call it buckets. If you had 10 buckets of sand, you would put 1 bucket of cement in there. And that would be at least quite a hard mixture between 5 and say 7 MPa. If you wanted to go slightly harder, I would use like 2 cement, which makes it about about 15% cement in the mix. That's probably guaranteed to give you a good rammed earth mix with about 15% cement. And then can you take the shutters off straight afterwards? Yes, not straight afterwards, but the next day. So we'd like to leave cement stabilized in the shutters for 1 day, and the next day you can move the shutters up. So it basically, it's hard enough to move up. If you're stabilizing with lime or clay, then I would leave it for at least another day. So I'd say 2 days before you move the shutter. Lime takes a very long time to go hard, so you have to leave at least 2 days before you
So
move the shutter. And as you're ramming, you just carry on ramming. So your first shutter's on, the next day you just bolt the next one, you ram, you bolt the next one, you ram. You don't have to actually wait for it to set underneath before you can bolt on and carry on going higher. Okay, I don't know what else. That's the end of the questions, I think.
Yeah, I mean, one is asking like, I mean, there we have 2 questions. Do you face capillary rise of moisture from the bottom of walls? Capillary rise, it's like this sipping of water, I think.
Yes.
Yeah.
Yeah. So on top of our foundation, we always try and put a plastic layer on there so that you're not getting water that's coming from the foundation in through the wall. And when we start doing our shuttering, the first shutter that we put in a concrete layer. So inside that actual shutter, we build a concrete layer into that. And that's just to lift the rammed earth above your outside soil levels. So you basically just want to get your rammed earth started at a higher level to outside. So I go for about 250 to 300, and then I start my rammed earth. So that first layer is either river sand with a lot of cement layer, or it's a concrete layer. And then I'll start my rammed earth. So about 300 above outside ground level. And that will stop, moisture or the rain splashing against the wall or that sort of thing. So that will stop that moisture ingress.
Okay. So when do you know when to start a new layer?
Oh, well,
That's another question.
yeah, we do it straight away. So once we've rammed a layer, we pour the next layer, we ram it. So there's no waiting. You don't really have to wait. Once it's been compacted into the shutter, you just carry on. A cold join. So let's say I came back the next day. If I wanted to join onto my wall, then I would wet the wall, put a small line of cement down the center of the wall, and then just carry on ramming again. So you're basically just creating a cement join between the 2 layers. So that's a cold join, yeah.
Next is like, can you build a story with rammed earth without a concrete beam intervention?
Yes, absolutely. We've done a lot of buildings here in South Africa, obviously with no earthquakes, where we don't use a concrete ring beam on the top because the rammed earth is actually stable enough by itself. And then reinforcement only in concrete. Absolutely, yes, you can put steel into rammed earth. When you're building rammed earth walls off of a foundation, it's nice to have a starter bar that comes up out of the concrete. So basically you've got your concrete layer, you've got the bar coming out, and you ram around that bar, and it works very well in rammed earth. So rammed earth, really attaches well to steel reinforcing.
Mm. So, um,
Yeah, we're getting through there, man.
so I think we are almost done, right?
I think so. I think in a
Mm,
nutshell, rammed earth as a product, because it's coming out the ground. So as far as the economic um, properties of rammed earth would be that if you're harvesting your own sand, you're going to be able to build a cheaper building. If you're buying sand in, it's going to be an expensive building. The properties of cooling and heating are much better than any conventional product because of the thermal mass. So when you're building rammed earth, just make sure you're following the principle of building east to west. So the longer part of your building is east to west. Make sure you use the sunlight to heat it and cool it. It works very well. Remember that in a cold climate, you would have to have additional thermo properties because rammed earth temperature will just keep dropping, or it will just keep getting hotter and hotter if you haven't got the capabilities of shade or anything like that. The type of labor you can use is any unskilled laborer can build rammed earth, as long as you've got one guy there who's looking after the quality of the mix, which is very important, and obviously the setting up of the shutters. So I think it's very doable for any person to actually just do some studies online on rammed earth, do a few samples in your garden, and before you know it, you'll be building rammed earth. I'll make it sound very easy, I know.
yes, actually. Um, so I think uh, so if anyone has question, then we
Yeah, I
can.
think our websites are open. So, I mean, they can ask you on Aankura or even on Rammteck. Yeah, I'll be answering questions. It's not a problem. As soon as I see it, I'll give you an answer. Yeah.
So yeah, so if people, if you guys want to have more information, then please visit. I mean, please check on Rammteck on Facebook page, as well as you can find blog of Michael Beukes.
Yeah.
That has the explanation of different projects over there, and lots of pictures also.
Yeah.
And I think lately Mike has been also sharing the videos of this construction techniques as well. So it would be really useful for you all to check on Facebook page of Rammteck.
Yeah.
So
And
I
on the
think
yeah.
that's it. Actually, we had only planned for 45 minutes, but Zoom Zoom was kind enough to grant us extra time. So
Oh, wow.
I
Awesome.
think we have already talked nearly like more than 1 hour and some
Oh, wow.
few minutes.
Okay. That's
And
amazing. Thank you. Thank you, everyone, for joining us. And thank you, Pragna, for setting this up. That's been amazing. It is nice to reach all over the world and to share this kind of information. And I mean, I think our whole company is about empowerment. So if someone can take from this call, get the confidence to go ahead and do something like this, that's amazing. That's what the call was all about, was just to get us confident in rammed earth, and just to show you that anyone can do it. It's not something, you don't have to be a specialist to do it.
okay, so I think we had uh, so yeah, so um I think that's we can wrap up now, right?
Thank you.
So
Yeah.
yeah, thank you so much, Mike. You have already said whatever I was supposed to say. So thank you so much, Mike, for being here. Actually, he just accepted our proposal of being in our conversation, and like it was very. I mean, he was very easy and very kind to us to join us today. So thank you so much, Mike. We are
Thanks.
very grateful to have you here. And I think lots of people in comments, lots of participants in comment sections are also saying same like thank you, thanks a lot to you, Mike. So
Yes.
uh, from yeah, so thank you so much to all the participants. This was the this was our very first attempt of conducting a webinar and having some professionals expert in something and getting to learn in virtual way or among this corona pandemic. And I
Yeah.
think given that it is our first attempt and we had a good participation from different countries, thank you so much for being with us here today. So I think I didn't mention in the first place, this is just the first webinar of Aankura. We will be having other follow-up, other series as well. I mean, all the webinars as well. So focusing on the or featuring the different ecological practitioners and environmental warriors all around the world. And yeah, we don't want to limit ourselves within the architecture alone. We plan to have different peoples working in the forest, working in biodiversity, working in lake cleaning up and empowerment and all. So keep I mean, stay tuned with us for all the informative sessions and all. So also, I would like to, in case of any kind of shortcomings from our side, I would like to apologize, and I would like to uh, say that you can send us the comment, and then so that we can improvise in it in future sessions.
Yeah.
So I guess we are good to good to say good. I mean, bye to Mike and all the participants now.
Thank you.
And yeah, thank you so much to everyone, to all the participants, and to Michael Beukes, and to our team members of Aankura, and especially the one Mr. Ashish Taka, who is supporting us technically right now. So
Thank you.
thank you
Yeah.
so much, Mike. Okay, see you all in all the sessions. Thank you so much.
Thanks, Pragya. Chat soon. Thanks. Bye.